Hello, today we're going to talk about temperature and volume changes in gases. Alright, temperature is not the measure of heat, it's the measure of average kinetic energy of a substance. Alright, what we're talking about today, temperature and volume, they have a direct relationship together. So as temperature increases, velocity increases. Unlike when we did Boyle's law, pressure and volume, they're indirectly, so pressure would increase and volume would go down. Both of these, as temperature increases, your velocity increases because as you're raising the temperature, you're adding energy to something which speeds it up. We're talking about thermal expansion today also. So what thermal expansion is as something heats up, it expands. So if you look at like the street lights or the lights, the stop lights in the road. So if you notice it, that wire right there is not completely pulled together, taut, I think the word is. It's not completely held together, it has a kind of lean in it. That's due to thermal expansion because during the summer, that wire heats up and it sinks a little bit. But during the winter when it gets real cold, it pulls tighter because it's contracting. Right? Thermal expansion means as something heats up, it's going to expand. As something gets colder, it's going to contract. It's the same thing with cement when you have large sections of it. That's why you see cracks in large sections of cement, because it heats up, it pushes against it, and it cools down and it shrinks, and that causes the cracks. I believe that's why sidewalks are the way they are, that they have little spots every time to equate for the expansion and contraction. Bridges do it too. Another thing we need to talk about is absolute zero. Absolute zero is when everything stops, right? It gets so cold that it stops. It's kind of theoretical. It's negative 270 degrees Celsius or 0 degrees Kelvin. Kelvin's a new measuring scale for temperature. It's a temperature scale that starts at absolute zero. So to find the temperature in Kelvin, you take the temperature of the Celsius degrees and add 273 to it. And that is what your temperature in Kelvin is. So it starts, Kelvin, it starts at absolute zero or zero. When you get to 0 degrees, that means nothing is moving anywhere. Everything is gone, everything is stopped. Right. An example of this, if I say I have 45 degrees Celsius, what is that in Kelvin? Well, 45 plus 273. So the Kelvin degree would be 812, oh, not 812, what am I talking about? 8, 11, 318 degrees Kelvin is the same thing as 45 degrees Celsius. If I have 18 degrees Celsius, all I have to do is say 18 plus 273, which gives me 291 degrees Kelvin. Now what if I said I have 96 degrees Kelvin? What is that in Celsius? Well, it's just like a regular equation. All I do is put the x in for there, subtract 273 from both sides, and I get, just because it's late in the day, I want to make sure I don't mess this up, 177. So 96 degrees Kelvin is 177 degrees Celsius. Is negative 177 degrees Kelvin. So we're going to add that together to 1310. Alright, yep, that's right. So that's how you figure out Kelvin, and that's what Kelvin is. Alright, now we're going to talk about Charles' law. So in another video we talked about Boyle's law, now we're talking about Charles' law. It has to do with volume and temperature. Alright, so Charles' law is the volume of a gas varies directly with the absolute temperature, provided pressure remains constant. So pressure constant, and the temperature is measured in kelvins. That's why we learned how to do it. Alright. So example 1. So if I have a volume of 605 liters, my temperature is 27 degrees Celsius. I have a new temperature of -3. What is my volume? Alright. So I'm going to call this my ones and this my twos. It really doesn't matter as long as I have them separated correctly. So I'm going to switch my temperature right now to Kelvin. So I'm going to add 273 to each of these, and I get 300, and I get 270. So then I just plug everything into where it's supposed to go. So 605 over my temperature, which is now 300 degrees Kelvin. I'm looking for my second volume over my temperature of 270. I cross multiply, and I get 1,63350 equals 300x, which is 544.5 liters. That is how you do Kelvin. Charles' law, not Kelvin's law, Charles' law. We'll do one more example real quick. All right, here's our next example. So list everything out that you need to find first. So my first volume is 1. I don't know my second volume, that's what I'm looking for. My first temperature is 196, but I have to add that to 273. And I get 77. And here I already know what that's going to be because I already did 270. So I do 1 over 77 equals x over 270. So 77x equals 270. And my final answer is 3.5 liters. So that is how you use Charles' law, temperature in Kelvin with the pressure constant. All right, the last thing I'm going to talk about is something called ideal gas. So scientists came up with this idea of a gas that went perfectly with everything they needed to be and never changed. So an ideal gas is a hypothetical gas that perfectly obeys all gas laws. Because that doesn't always happen, they came up with an ideal gas that allows them to do all their math and everything and figure out stuff a lot easier. All right, this has been temperature and volume changes in gases. Hope it helped. Good luck.